Now, tan 150, as I told you before, I can solve it as sine 150 over cosine, or I can solve it using this identity. It is the square root, positive or negative, the square root of 1 minus cosine A over 1 plus cosine A. Now, since 150, it is between, it is in quadrant 2, so the whole the tan is negative. Square root of 1 minus cosine 300, we say that it is 1 over 2 over 1 square root of 1 plus 1 over 2. So it is square root of 1 over 2 over square root of 3 over 2. The square root of 1 over 2, 1 minus 1 over 2, yes, it is 1 over square root of 2 over square root of 3 over square root of 2. So it is negative 1 over square root of 3. Another example now. Use a half angle identity to find an exact value of each expression. Cosine 22.5. I will rewrite it as 45 over 2. Then it is positive or negative square root of 1 plus cosine 45 over 2. Now, since now 22.5, it is in quadrant 1, so it is positive square root of 1 plus 1 over square root of 2 over 2. Why? Because I used this one, as you see here. Now, it is positive square root of 1 plus 1 over square root of 2. It will be square root of 2 over square root of 2. So it will be square root of 2 plus 1 over square root of 2 over 2. It will be 2 square root of 2. Now, on calculator under the square root, I'm sorry for the delay. It is 0.9 positive 0.923. If you check it as a cosine 22.5, you will find that also it is 0.29238. So that's how can we find cosine 22.5 without using the calculator, using the half angle identity. What about now tan? I mean 22. Tan 22.5. It is tan 45 over 2. It will be positive because the tan in quadrant 1 is positive. Square root of 1 minus cosine 45 over 1 plus cosine 45, which is 1 minus 1 over square root of 2 over 1 plus 1 over square root of 2 under square root of 2. It will be square root of 2 minus 1 over square root of 2. After I subtract, then because since they are not the same denominator, I write it here as square root of 2 over square root of 2. Then I subtract it, and down it will be square root of 2 plus 1 over square root of 2. So it will be the square root of 2 minus 1 over square root of 2 plus 1. Now, here in problem 5, we have now cosine. They give you that the sine of theta is negative 24 over 25. Okay, what about sine of theta over 2? Now, you know that if I want to use sine of theta over 2, I need cosine. So since I need cosine, I need now to find the cosine using the sine. How? Using the Pythagorean theorem. So know that sine squared of theta plus cosine squared of theta is equal to 1. Sine squared is negative 24 over 25 squared plus cosine squared of theta equal 1. So cosine of theta is square root of 1 minus 24 over 25 squared. So it is square root of 1 plus, using the calculator now, 24 over 25 squared. As you see now, this one, I'm sorry, there's something wrong. Cannot be 1 and it is 1 minus, that's why. It is 7 over, so what 1 over the answer, square root of the answer, it will be 7 over 25. Now positive or negative? Since I am in the quadrant here, 180, 270, so I am in quadrant 3, so the cosine also is negative. So it is negative 7 over 25. Okay, now I want to find now sine of theta over 2. It is positive or negative square root of 1 minus cosine, which is negative 7 over 25 over 2. Here the square root is included afterwards. So it is 1 plus 7 over 25, which is 25 plus 7. It is 32. So it will be 32 over 25 over 2. So it is 32 over 50, square root of it. Square root of 32 over 50, which is 4 over 5. Now you ask me why I did like this. Look here, it is 1 minus negative 7 over 25. This one, it's as if I make it as the same denominator, it is 25. 25 plus 7 is 32 over 25, okay, over 2. Then the denominator here is 32 and the numerator sorry, is 32 and the denominator is 25 times 2. Why? Because if you have A over B over C, it is A over BC. This is a rule. So here it is will be square root of 32 over 50, which is 4 over 5. Now positive or negative. For the theta, here, if you look at the domain of the theta, it is between 180 and 270. Okay, this domain is given from the above. Now, if I told you that, since I told you that 180, it is the range of theta, what about theta over 2? It will be over 2. So the range of theta over 2 is between 90 and between 135. Okay, now this 90 and 135 in which quadrant? It is in quadrant 2. And in quadrant 2, the sign is positive or negative? It is positive. That's why I choose only positive 4 over 5. Now, here now we have, if you have that cosine theta as a 3 over 5, and the domain of theta is between 270 and 360, find the exact value of each expression. Now, Here we have, as a revision for the lesson, sine, this is for 41, sine 2 theta. It is 2 sine theta cosine theta. So it is 2. What is the sign here? It is unknown. So I have now to find the sign using the Pythagorean theorem, which is cosine square, sine squared, or 1 minus cosine squared is sine squared of theta. So 1 minus 9 over 25 is sine squared of theta. So is it 25? After I make it at the same denominator, it will be 16 over 25 is sine squared of theta. Under the square root, so sine theta here is 4 over 5. Now, this is what now? It is the sine of theta. Now, since it is between 270 and 360, so it is, I'm talking here about the quadrant 4. So the sign here is negative. Okay, now, so 2 negative 4 over 5 times 3 over 5, which it will be 4 times 3 is 12 times 2 is 24. 24 over 25, but here was what? With the negative sign. Okay, now I want now to find the cosine of 2 theta. Did you remember what are the formulas of cosine of 2 theta? I want to solve it here now, please. But let me. Now, cosine 2 theta, as we said before, it has 3 formulas. I can find it as cosine squared of theta minus sine squared of theta, 2 cosine squared of theta minus 1, or 1 minus 2 sine squared of theta. Let's try with the main one, which is I'm sorry, the same problem is happening now.